Hello and welcome to this video in which we will be learning about atomic bonding. Now, atomic bonding is basically the reason why molecules exist. Any two atoms, when they come together, they could be the same atoms, like for example, H and H, or they could be two different atoms, like C and H. They form a bond. Now, a bond is simply an interaction between two or more atoms of some kind. They could be a metal and a non-metal, or they could be two non-metals. It is important to note that a metal and another metal don't really form any kind of a bond, even though we will talk about metallic bonding in a subsequent video. I don't want you to think that two metals can form a conventional type of bond. So what are we going to learn in this video? In this video, I'm going to focus on three main topics. Those topics are: what is electronegativity? You have already learned about what is electronegativity, but we are going to cover that in a greater detail in this video. Then we are going to talk about the relationship between chemical bonding and electronegativity. And last but not least, we are going to compare the properties of ionic and covalent compound. In other words, what are some of the telltale signs that you can look at, mostly physical properties, that will help you determine if a substance is ionic or covalent. So let's start with the first topic, which is what is electronegativity? Electronegativity, simply put, is the tendency of an atom to pull a pair of electrons towards itself. Now, it is important to remember that electronegativity is not a measured value. Okay, in other words, electronegativity is not something that you can find by measuring something. So it doesn't have any units. Instead, it is relative. We take the most electronegative element and we give it a value of 4, kind of like how your GPA is, right? So for example, you must have learned from the trends in periodic table that the most electronegative element in the entire periodic table is fluorine. And then you take all the other elements and compare them to fluorine. Now I know over here fluorine says 3.98, but you can count that as 4. And it is important to remember that this is just a relative value. It's kind of like how if you take a test in your class and the highest grade is an 85. But if I say that if I take that 85 and make it 100, then what did the rest of you score in relationship to that 100 grade? Okay, so you can think of electronegativity as a scaled score. So now let us take an example of the two elements that you see on the slide over here. You have lithium and you have fluorine. Lithium, as we know, is a metal, and fluorine is a non-metal. So let's find these two elements on the periodic table. Fluorine is right here as 3.98 and lithium is over here as 0.98. So lithium is 0.98 and fluorine is 3.98. Now, using electronegativity values, we can identify the kind of bond. And the rule of thumb is, if the difference in electronegativity is more than 2, then the bond is ionic. So let's quickly talk about what does that really mean. Say, for example, lithium over here has only one valence electron. And there it is. Has only one valence electron. Fluorine over here has 7. Now, as you must have learned, that all elements want to have 8 electron in its outermost orbit. In this case, lithium only needs 1. So when lithium, I meant fluorine only needs 1. So when lithium and fluorine come together, fluorine is highly motivated to gain that electron. So in reality, it is not going to share that electron. What it's going to do is it's going to take this electron and simply take it from lithium. Now lithium, on the other hand, is also happy because now it has only 2 valence electrons left in its outermost orbit, which we need to remember that yes, all atoms want to have 8 electrons in its outermost orbit. However, if the orbit in the question is the first energy level, then 2 electrons is perfect. Okay, so lithium is perfectly happy in having 2 electrons in its outermost energy level. It gives up its electron and becomes stable. Fluorine gains this electron and now it has 8 electrons in the outermost energy level. So I will make this in white so that you know that it is the electron that it gained from lithium. And now it has 8 valence electron in the outermost energy level. A periodic table where it tells us the electronegativity values, you will notice that carbon is 2.55, hydrogen is 2.20. So let us go ahead and know. Oxygen is 3.44 and hydrogen is 2.20. So that's an electronegativity difference of 1.2 something, 1.24, which is fairly large. And so the sharing of electrons between oxygen and hydrogen is not going to be equal. Oxygen will try to keep an unfair share of electrons when they share the electrons. Okay, so that is called a polar covalent bond. On the other hand, if oxygen and chlorine share electrons, then oxygen is 3.44 and chlorine is 3.16. That's a pretty small difference in electronegativity. So this type of bond will be a non-polar covalent bond. Now let us take an example of 2 elements, carbon with 4 valence electrons and hydrogen with only 1 valence electron. If we go back to the down, carbon was 2.55 and hydrogen was 2.20. So what is the electronegativity difference between these two? Well, it is barely a difference of 0.35. It means that when it comes to pulling electrons towards itself, carbon and hydrogen are pretty even Stevens. One is not vastly powerful than the other. So when they share electrons, that sharing is going to be pretty even. Okay, and that's how we know that this is going to be a type of covalent bond. Meaning that carbon is not going to be able to just take this electron away from hydrogen, or hydrogen is not going to be able to take the electron away from carbon. If electrons are exchanged, in other words, if an electron leaves one atom and goes to another atom, it's an ionic bond. But if the electrons are simply shared, it is a covalent bond. By sharing, what does an atom gain? This carbon atom has now 5 instead of 4 valence electrons because it gets to count this as its own. But the hydrogen atom also gets to count this electrons as one of its own. So now hydrogen is happy and so is carbon. This brings us to the last thing we need to go over before we compare and contrast the ionic and covalent bonds. You can think of all chemical bonds as either ionic bonds or covalent bonds. Ionic bonds are when you compare 2 elements and their electronegativities, and if their difference is more than 2.0, it is an ionic bond. So for example, the difference between sodium and chlorine is more than 2.0, so it is an ionic bond. Covalent bonds, however, are of two kinds. They're called polar covalent bond and non-polar covalent bond. The difference between these two we will go over in a greater detail when we learn about hydrogen bonding. For now, we just need to be able to remember that if the electronegativity difference is between 1.9 to 0.6, then you will consider that as a polar covalent bond. And if the difference is 0 to 0.5, which is very little, it is a non-polar covalent bond. In a nutshell, you should remember that a polar covalent bond, the sharing is not equal. Like for example, hydrogen and oxygen, which are the two elements that make water, the electronegativity difference is fairly large. And then as far as your exam goes, you need to be able to look at a molecule, see what elements are making that molecule, and then figure out if that element is either if that chemical is either an ionic compound or a covalent compound. Last thing we're gonna go over is what are the different properties of ionic compounds versus covalent compounds. It is important to note that sometimes we will also refer to covalent compounds as molecular compounds. So these are all the different properties, different physical properties of ionic and covalent compounds. So you can pause the video and note these down in your notes. The questions over these topics are fairly common, so please be sure to note all of this down. And as always, if you have any questions, let me know, and take good notes, and I will see you in the next video.